Okay, complex numbers. What? You don't have one of these? Here, here's a package. Okay, the number I in math is the square root of -1, which you have learned in the past. You obviously can't square root a negative number. So this is called an imaginary number. So the whole time, your 12 years of learning, whatever, you have always learned about real numbers. Real numbers. And now this is an imaginary number because we cannot square root a negative number. Okay, so when I do this kind of work, this is simply just collecting like terms. So I can put 16 and -5 together. So that's 11. And I can go 2i plus 7i is plus 9i. Okay, when you do this question, you'd have to be careful because you'd have to distribute brackets. So I'm just going to rewrite this as 9 plus 4i. And then this would turn into a plus a 4. And this distribution would turn into a plus 5i. So you might have to distribute brackets first. Then my final is 13 plus 9i. Okay, so just collecting like terms. Okay, now I'm just going to go over here and I'm going to make a chart. So I is the square root of -1. So that's what we know. What would I squared have a value of? So if you squared that, you would get -1. Because the squaring of the square root would just cancel off. I cubed would be I squared times an I, which would be -1i. Because I squared was -1 and then times it by another I. I to the 4th would be the same idea as doing an I squared times an I squared. So what would that turn out to be? So I'm going to go back to the I squared. So what is -1 times -1? +1. Okay. I always base everything off of I squareds when I do my math. Some people like to work with any of these values. It's up to you. Okay, so on this question, 6 times I squared. So 6 times -1 equals -6. Okay, and again, if you are not understanding where I'm getting the -1 from, so I'm gonna, if I replaced I with the square root of 1, but then squared it, right? That's what's happening with the I squared. Okay, next question. Let's distribute that. So I get 10i squared plus 14i. I see an I squared. So what can I replace I squared with? I squared is -1. So this would be -10 plus 14i. Okay, and you cannot go any further when you have an I. An I is as low as an I goes, but an I squared can change. This question, you're squaring a binomial, so don't forget when you square binomial, it creates a FOIL system, right? We square the unit. We don't square the individual stuff. We square it as a unit. So give me a FOIL on that. Okay, now I squared is -1. So this is really a -4 now, minus 12i plus 9. Then after I do that, I can put the number values together. I can put a -4 and a 9 together. So 5 minus 12i. And that's, again, as far as you can go. You can't go any more with an I. Okay, the next one says I to the 80. So here's what I like to do. I like to take out I squareds. So I can change this to be I squared to the 40. Does that make sense, what I just did? Instead of I to the 80, I just revamped it to I squared repeated 40 times. So now I squared is -1. And if you repeat -1 40 times, what do you get? +1, right? Okay, I to the 19, I'm going to go I squared out. Now, I can't get up to 19, right? There's no way I can do 2 times something to be 19. So I'm going to get up to 18. So 2 times 9. So that is I to the 18. And then another I. Do you see how I'm at 19 right now? I to an 18 and then a 19. Okay, when it's odd like that, I can't get an I squared perfectly. Now I'm going to replace I squared with -1. -1 repeated 9 times would turn out negative. So that would be a -I. Okay, let's try the same thing here. 21 we're not going to get to perfectly. So I squared, I'm not going to get to 21, so I'm going to just try to get to 20. So I'm going to put a 10. So that's an I 20. One more. Now I'm at 21. I squared -1 to the 10th. So this is +1 times an I. So just I. So I cubed, we did that one in our chart, but to see it again, we can do an I squared, and then another I. So I squared is -1, so -I. Okay, so this one, we're going to treat it a little bit differently. There's a negative in there. So I want you to think about it like this. -1 and I want you to separate them. So I'm going to separate them like that. They both have a 15 on the top of them though. So this is the coefficient part, and this is the variable part kind of idea, the I part. So this would be a -1. I'm going to break this down with an I squared. So again, I'm not going to get to 15, so let's try to get to 14. So 7 and an I. Okay, so we had this number part. That was a separate thing. That's the coefficient part. And then I squared is -1 to the 7th times an I. So now -1 to the 7th is -1. Final answer, I. Okay, because -1 is +1. Okay, this last example, we're going to do the same way. We're going to treat the coefficients separate than the I parts. So here I'm going to separate. So 2 cubed, I cubed. 2 gets cubed, the I gets cubed. There's a -1 gets to the 9th and an I that goes to the 9th. Okay, so coefficients and the i's, you got to attack them both with the exponent. So we have an 8 and a -1. So this is here, this is here. So some of you might have just wrote -8. I to the 12th. I can put that together right now. Okay? Does that make sense? The coefficients, I've moved them all to the front. I to the 12th. Then you got to do your I work. So I squared can come out of that perfectly with a 6. I squared is -1 to the 6th. All that is +1, right? +1 times the -8. So then -8. Okay, we kind of did something like this in grade 10 and 11, where you break that down. So the square root of 100, -100, could be separated like that. The square root of 100 times the square root of -1. Okay, do you remember kind of doing that in grade 11? And then, what is the square root of 100? 10. What is the square root of -1? I. Okay, same thing here. The square root of 8 and the square root of -1, that can separate them to be equal. That's the same thing. Now this is a little bit different. The square root of 8 isn't a number that we know, but do you remember breaking radicals down more? The square root of 8 could be written as the square root of 4 times the square root of 2. square root of negative 1 is going to be an I. So this is going to be the whole number 2, so just 2 root 2 I. Okay, I'm just going to do one on the side here. I'm just going to do one more. So if I did something like that, square root of negative 75. So I'm going to break it down, the square root of 75 and the square root of negative 1. Then 75, what perfect square? You got your perfect squares in your head. You can divide 75 by 25 times 3. Do you remember doing that? We did that stuff in grade 11. So this is 5 root 3 I. Okay? All right, let's do a cubed. We're going to be doing some big time foiling here. Okay, let's foil 2 of them together. So 9. Can I do my outsides and insides together that I get a 15 and a 15, so I'd be getting 30i? Will you be okay with that? Plus 25i squared. Okay, does everybody know how to multiply a trinomial times a binomial? Do you see all your combos? You got to do first times first, first times last, second times first, second times last. So you're going to have six sets of things, right? Do we match on just the distribution of the 6? That was okay? Am I good? Okay, collect like terms when you're done here. So 27 is with nothing. 45 plus 90 can go together. The 150 and 75 can go together. Okay, so this and this we're going to not do anything with. So this is -1, so this term would turn out to be subtracting 225 now. Some of you might have I cubed just straight memorized, or I squared times an I, which makes -1I. So this term would turn into -125I. Okay, combine, combine. There's your final answer on that one. How did it go? Did you get there a little bit? I think this is the last question here. Yep. Okay, rationalize. We have learned the word rationalize when we did radicals in grade 11. And we learned the word conjugate. Does that ring a bell? So rationalize would mean you can't have an I in the bottom. At the end, you're not allowed to have any I's in the bottom. So we're going to times by the conjugate, which is 2 plus 4i. Do you remember that now? The conjugate is doing kind of like a difference of squares idea. Obviously, if you do something to the bottom, you would have to similarly do it to the top. Okay, the top you're going to need to FOIL out. Do you remember how to FOIL a conjugate? Do you remember what would happen? When you do conjugates, look at my outside is 8i and my inside is negative 8i. So we can always just flip conjugates because that would always happen. Okay, go ahead, start your work on your own. Let's see if we can get there. So you go, I'll go and see if we can match up here. Bless you. Did we get these same numbers, the 2 plus 14i over 20? We got to that part? Okay. I'm not sure, some places might be just done with that, but some places might do this where they separate that as a 2 over 20 and a 14i over 20 separated. And also on this one, you can see that each thing could also be divided by 2. So I'm not sure how you might see it, but just be aware that those might get split apart. In this case, I could have reduced them as well, but okay.